Hello everyone, this is Dharamveer sir here. So today we are going to continue with chapter 10 of grade 11 maths, which is straight lines. And the topic of today's video is various forms of the equations of a line. In the previous video we have learned about equations of line. Now we are going to learn about different forms of equations of a line. So let's start. Now first we have horizontal and vertical lines. So if a line is parallel to x-axis, as you can see we have y equals to a or y is equal to minus a parallel to x-axis. In that case we take y is equal to constant. If it is on the positive y-axis we say y is equal to plus a, and if it is on the negative y-axis we say y is equal to minus a. And as in the second figure, if it is parallel to y-axis as x equals to b or x equals to minus b, then we take x equals to constant. Same as y, that if it is on the positive x-axis we take x equals to plus b, and if it is on the minus x-axis we take x equals to minus b. So we have two forms, parallel to x-axis and parallel to y-axis. Clear? So pause and note down this point. Next is point slope form. Now you can see the figure that we have 2 points, a point x0 y0 on a line with the slope m. The slope of the line is m. Then the equation of the line is given as y minus y0 equals to mx minus x0, where xy p, you can see the point p, xy is any point on the line. So if the point x0 y0 is given and the slope m of the line is given, then the equation of the line is obtained by y minus y0 equals to mx minus x0. This is called point slope form of a line. Clear? Next is 2-point form. That is if 2 points on a line are given. In the figure you can see we have point P1 x1 y1 and P2 x2 y2 on the line is given. So taking an arbitrary point P on the line, the equation of the line is obtained by using y minus y1 equals to y2 minus y1 upon x2 minus x1 multiplied by x minus x1. Clear? So if we have 2 points on a line given, then the equation of the line will be obtained by using this formula: y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. Clear? So pause and note down this point. Next is slope intercept form. So if the slope of a line m is given and the intercept on the y-axis is given, as you can see the intercept on the y-axis is c, so the coordinate of the point is 0 c. Then the equation of the line is obtained by y is equal to mx plus c, where m is the slope of the line and c is the intercept on the y-axis. If it is on the positive y-axis we take plus c, and if it is on the negative x-axis we take minus c. Clear? So pause and note down this point. Next we have intercept form, that if a line is intersecting the x and y axis at 2 points, x at a0 and y at 0b, then the equation of the line is obtained by x upon a plus y upon b is equal to 1, where a and b are the intercepts on the axis respectively. Clear? So pause and note down this form. Next we have normal form, that is the perpendicular distance of a line from the origin is known, that is p, and the angle that the normal, that is the perpendicular, is making with the positive x-axis omega is known. Then the equation of the line called as normal form is obtained as x cos omega plus y sin omega equals to p, where p is the perpendicular distance of the line from the origin and omega is the angle made by the perpendicular with the positive x-axis. Clear? So pause and note down this point. So let's start exercise 10.2, and first we have find the equation of the line which satisfy the given conditions. So first is write the equation for the x-axis and y-axis. Now we know that if a line is parallel to x-axis it is y is equal to constant, if it is parallel to y-axis it is x equals to constant. Now since x-axis means what? Any point on the x-axis have the y coordinate as 0. So the equation of x-axis is y is equal to 0. And similarly, any point on the y-axis, then the x coordinate will be 0. So equation of the y-axis is x equals to 0. Clear? So pause and note down the solution. Next is question 5. Intersecting the x-axis at a distance of 3 units to the left of the origin and with slope -2. So we have the x-intercept as 3 units to the negative direction and the slope as -2. So using the slope intercept form, we have y minus 0 equals to -2 into x minus 3. So simplifying, we get y is equal to -2 into x plus 3, or y is equal to -2x minus 3. So writing in the standard form, the equation of the line is 2x plus y plus 6 equals to 0. Clear? So pause and note down the solution. Next is question 8. Perpendicular distance from the origin is 5 units and the angle made by the perpendicular with the positive x-axis is 30 degree. So if you remember the normal form, the perpendicular distance p is 5 and the omega is 30 degree. So using the normal form, we know x cos omega plus y sin omega equals to p. So we get x cos 30 plus y sin 30 equals to 5. And putting the values, we get x into root 3 by 2 plus y into 1 upon 2 equals to 5. So simplifying, we get root 3x plus y equals to 10. Clear? So pause and note down the solution. Next is question 9. The vertices of triangle PQR are P 2 1, Q minus 2 3 and R is 4 5. Find the equation of the median through the vertex R. So we have to find the median equation, that is we have to find the equation of RM. Now since M is the midpoint of PQ, so finding the coordinate of M using midpoint formula, we get M is equal to 2 minus 2 upon 2 into and 1 plus 3 upon 2, which is 0 and 2. So we have the coordinate of M as 0 2 and R is 4 5. So we have 2 points, so we can use the 2-point form. So using the 2-point form, equation of the line RM will be y minus 5 equals to 2 minus 5 upon 0 minus 4 into x minus 4. So simplifying, y minus 5 equals to 3 upon 4 into x minus 4. So writing in the standard form, we get the equation as 3x minus 4y plus 8 equals to 0, which is the required equation of the median. Clear? So pause and note down the solution. Next is question 11. A line perpendicular to the line segment joining the points 1 0 and 2 3. Divide it in the ratio 1 ratio n. We have to find the equation of the line. Now slope of the line joining A and B, the points, we know how to find the slope. Slope is y minus y1 upon x2 minus x1, which is 3 minus 0 upon 2 minus 1, that is slope of the line is 3. Now the required line is perpendicular to AB, so slope of L will be equal to what? Negative inverse. So slope of line L becomes minus 1 upon 3. Now it is also given that the line L is dividing the line AB in the ratio 1 ratio n. So using the section formula, we can find the coordinate of P as 1 into 2 plus n into 1 upon 1 plus n, comma 1 into 3 plus n into 0 upon 1 plus n. So the coordinate of point P are 2 plus n upon 1 plus n and 3 upon 1 plus n. So we have a point on the line L and its slope. So using the point slope form, we get the equation as y minus 3 upon 1 plus n equals to minus 1 upon 3 into x minus 2 plus n upon 1 plus n. So cross multiplying and simplifying, we will get the equation of the line as 1 plus n into x plus 3 into 1 plus n into y equals to n plus 11, which is the required equation of the line. Clear? So pause and note down the solution. Moving to question 14. Find the equation of the line through the point 0 2, making an angle 2 pi by 3 with the positive x-axis. Also find the equation of the line parallel to it and crossing the y-axis at a distance of 2 units below the origin. Now the line is passing through 0 2 and the slope is tan theta, that tan 2 pi by 3, which is equal to tan pi minus pi by 3, that is minus root 3. So we have the slope minus root 3 and the point 0 2. So using the point slope form, we get the equation as y minus 2 equals to minus root 3 into x minus 1. So we get the equation of line as y minus root 3x plus 2. Now any line parallel to 1 also have the same slope, because parallel lines have the same slope. So it cut the y-axis at a distance 2 below the origin, so it is passing to the point 0 minus 2, because 2 below the origin. So the equation of the line will be y plus 2 into minus root 3 x minus 0. So y plus 2 equals to minus root 3x, or simplifying we get root 3x plus y plus 2 equals 0. So the equations of the required lines are root 3x plus y minus 2 equals 0 and root 3x plus y plus 2 equals to 0. Clear? So pause and note down the solution. Moving to question 15. The perpendicular from the origin to a line meets it at the point minus 2, 9. Find the equation of the line. And the perpendicular from the origin to a line meet it at a point minus 2, 9. Find the equation of the line. We have to find the equation of the line. Now slope of OA is equal to, using the slope formula y2 minus y1 upon x2 minus x1, we get 9 minus 0 upon minus 2 minus 0, which is minus 9, 2. So slope of OA perpendicular to L. So the slope of line L will be negative inverse. So slope of L is 2 by 9. So using the point slope form, equation of the line L will be y minus 9 equals to 2 upon 9 x minus 2. So cross multiplying and simplifying, we get the equation of the line as 2x minus 9y plus 85 equals to 0. Clear? So pause and note down the solution. Next is question 16. The length L in centimeters of a copper rod is a linear function of its Celsius temperature C. In an experiment, if L is equal to 124.942 when C is equal to 20 and L equals to 125.134 when C is equal to 110, we have to express L in terms of C. Now it is given that it is a linear function. So taking C along x and L along y axis, we have 2 points 20, 124.942 and 110, 125.134 in the xy plane. So by using the 2-point form, we get L minus 124.942 equals to 125.134 minus 124.942 upon 110 minus 20 C minus 20. We have used 2-point form, that is y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. So simplifying, we get L equals to 0.192.90 into C minus 20 plus 124.942, which is the required expression. Clear? So pause and note down the solution. Moving to question 20. By using the concept of equation of line, prove that the 3 points 3, 0, minus 2, minus 2 and 8, 2 are collinear. Now we have 3 points A, 3, 0, B, minus 2, minus 2 and C, 8, 2. So using 2-point form, equation of the line through A and B will be y minus 0, minus 2, minus 0 upon minus 2 minus 3 into x minus 3. So equation of the line AB will be 2x minus 5y minus 6. Now 3 points will be collinear if the third point C falls on line AB, that it will satisfy the line AB. So putting the value of x equals to 8 and y is equal to 2 in 1, we get that the LHS equals to RHS, that is this point 8 and 2, that is point C, it's satisfying the equation 1. So the 3 points will be collinear. Clear? So pause and note down the solution. With this, we end exercise 10.2. So solve the remaining sums of the exercise and also solve the examples given before the exercise. Thank you and all the best.